Good morning everyone. Today we are going to learn about elements, compound and mixtures for class 8. Hope during this pandemic times all are keeping sound and safe. So let's start with the topic elements, compound and mixtures. As we know, in previous classes we have learnt about matter. We have learnt what matter is. So what is matter? Matter is anything that has mass and can be perceived by our senses. That is mass which occupies space and can be perceived by our senses. This is what we know about matter, that is around us. So when we classify matter into pure substances and impure substances. What is the definition for pure substance? If I ask you what is a pure substance, you give an example like pure water, pure air. These things appear to be pure, but exactly if I tell you, these are not considered to be a pure substance. Water you can consider to be a pure because it is a compound, it is a pure substance. But still the water that we drink, the water that we use is still having some or the other impurities added to it. So again, a pure substance, exactly if you talk about a pure substance, is made up of only one kind of an atom. And when we talk about impure substance, as the word impurity suggests, there has to be something added to it. So matter on the terms of purity or in the terms of matter, it is classified into pure substance and impure substance. We have learned the previous classification for matter as on the basis of the states, that is solid, liquids and gases. Now on the basis of the kind of substance, the kinds of atom that is present, we classify it into pure substance and impure substance. When you see different things around you, when you see the window pane, when you see the fan, when you see the wall, when you see the table, you classify it into various categories. All these are a part of matter. Some you can consider to be as metals. Some present around us cannot be considered as metals. The air that you breathe in is having a mixture of many gases. Now these gases which are present like oxygen, like nitrogen, they cannot be made into wires. They cannot be made into sheets. So they are not considered as metals. Okay. So when we talk about pure substance, we should be knowing what is a pure substance. So a pure substance is a homogeneous material which contains molecules or atoms of only one kind. Further classification of pure substance is divided into or classified into elements and compounds. Okay, so when we learn about the homogeneous material, you can say pure substances are homogeneous material, but all pure substances are not homogeneous in nature. Like for example, if you take water and sugar, if you add a little amount of sugar in water, the water will make the sugar dissolve in it. So it is having a uniform composition. Now that water can be called as a sugar solution. But later on you cannot segregate that sugar from water after dissolving in it. So again it is a homogeneous material, but still it is not a pure substance. Okay, so when we study the characteristics of a pure substance, the first characteristic is it is homogeneous in nature, made up of same kind or one kind of an atom or a molecule. Then it has a definite set of properties. We have learned in our previous classes for class 6 and 7 that elements, compounds are considered to be a pure substance. So when we will further learn about elements, we will learn about why these are considered to be as pure substance, because they are having a definite set of properties. The composition of pure substance cannot be changed by physical methods. So these are the three basic properties on the basis of which you classify it into a pure substance. Now further, pure substances are of two types. One is elements, one is compound. We have learned that there are many elements present, around 118 elements present around in that periodic table, or in the entire universe there is 118 elements that are present. So these 118 elements, if you classify them, when we learn, when we see things around, you say that this is the metal, that this is the air that I am breathing, this is a gas that is present, this is the water that is present. So these are one part of the elements. So what are elements? Elements is again a pure substance which is made up of only one kind of an atom or same type of an atoms. Okay, and which cannot be separated by any chemical method, by any physical or chemical method. So what are elements? Elements are pure substance made up of same kind of atoms and cannot be further broken down or separated or divided by any physical or chemical methods. If we further classify elements, we classify elements into metals, non-metals, metalloids and noble gases. Now taking the very first classification, that is metals. You see the window panes, you see the iron rod, you see the fan working, you see some of the ornaments. Many things are around you which can be considered as metals. So what makes it different from a non-metal? How are metals different from a non-metal? The very first thing that when you see a metal is it is solid. It is a rigid body. It is a solid body. Any metal that you see, it's having a particular shape, it is having a particular weight, and it is a solid or a rigid body. The first thing that appears to be as metal. The second basic thing that you see when a metal is there, you see either it is having some kind of a shine over it, or it will not be having a shine, but it is having some kind of an appearance on it. So this particular property by which the metals exhibit a shine on them is called as luster. You see silver ornaments, you see gold ornaments, they appear very shiny. So this property of metals is called as luster. The next property that makes it differentiate from the non-metals is whenever you see the wirings that are present at homes, the wirings that are present in the domestic lines, you see many wires are running, covering it with a plastic cover there. But inside you see very thin wires, sometimes you see thick wires, you sometimes see on the domestic lines, the big wires that are running connecting one pole to the another pole. So this property of metal by which it can be made into wire, like for example I will show you. This is a wire. This is a wire. This is an aluminium wire. Now this is again a metal, but this has been made into wires. So the property by which a metal can be made into wires is called as ductility. What is this property called as? Ductility. Metals made into wires. Now the next property, which again differentiates it from the non-metals, you must have seen the aluminium foil. When your mother bakes something, cooks something, she wraps the food. If she wants to send somewhere, then she wraps the food. She wraps it in an aluminium foil. What is this aluminium foil? What is this aluminium foil? This aluminium foil is nothing else than the metal aluminium. Now how is this done? It can be made into sheets. The metal can be drawn into sheets, beaten into sheets. Many are there. Silver. When you go to a sweet shop, you see some of the sweets having a very shiny covering over it. Okay, so that is again the silver work over it, which is made into sheets. So this property of metal by which it can be made into sheets is called as malleability. What is this property called as? Malleability. Malleable, made into sheets, flat into sheets. Now the next property, whenever you strike a metal, whenever a metal falls down, whenever you hit a metal, the metal makes a sound. Oxygen doesn't make a sound. Nitrogen doesn't make the sound. Okay, so when the metal is being struck or being hit, or when it falls down, it makes some kind of a sound. So this property of metals, which it makes sound, is called as sonority. What is this property called as? Sonority. Sonorous. Metals are sonorous, produce sound. Then next is when you go to the kitchen, if you have gone to the kitchen, your mother's prepared food, either she prepares it in a stainless steel utensils or she takes any metal utensil to heat it. Metals are making the food get a heat faster. Why? Because metals are good conductors of heat and electricity. What are metals? Metals are good conductors of heat and electricity. That is why the metal wires are used. The metal wires are used in the lines, in the wires to connect the switch to the appliance, because it can conduct electricity, make the electricity flow from one end to the another faster. So what are the basic properties of metal? Metals are lustrous, they show a shine. Metals are ductile, made into wires. Metals are malleable, drawn into sheets, beaten into sheets. Metals are sonorous, sound. They produce sound. Metals are good conductors of heat and electricity. Just the opposite of metals are the non-metals. They don't show any luster like oxygen, like nitrogen. They are in the gaseous form. Either they are in the gaseous form or either they are in the solid form. But maximum of the non-metals exhibit the gaseous state. So they do not show any kind of a luster. Since most of them are in the gaseous form, so they do not exhibit the property of ductility. They do not show the property of malleability. They do not show the property of sonority. And neither are they good conductors of heat and electricity. But remember, always, exceptions are always there. Like as I told you, when you talk about metals, you talk about metals to be in the solid form. But, you see mercury in the thermometer, what is it? It is again a metal. And it is in which form? It is in the liquid form. Sodium, potassium, these are the two other metals. When we talk about them as solids, these are not in the solid state. They are soft solids. Both sodium and potassium, they are soft solids. So if there is some condition, there are some exceptions also. Okay, zinc, a metal which is neither malleable and not ductile. Tungsten, this metals are good conductors, but tungsten is a poor conductor of heat and electricity. So, just the opposite of metals is the non-metals. They do not show luster, they are not ductile, they are not malleable, they do not produce sound, and they are bad conductors of heat and electricity. Again, exceptions are there. Graphite, an allotrope of carbon. Carbon has two allotropes, one is diamond, one is graphite. Allotropes means having the same chemical constitution but different physical appearance. So, graphite is lustrous in nature. Iodine again has luster. Bromine is a non-metal which is liquid at room temperature. Bromine is a non-metal which is liquid at room temperature. Okay, so these are the two classification of elements. Elements are pure substances which are further classified into metals and non-metals, metalloids and noble gases. So when we talk about metalloids, the next is when we talk about metalloids. Metalloids are elements that show the property of both metals as well as non-metals. Show the properties of both metals and non-metals. Example for metalloids is, you have arsenic, antimony, bismuth, germanium. Arsenic, antimony, antimony, Sb is the strontium is the Latin name. Arsenic, antimony, germanium, bismuth. These are the metalloids which show the property of both metals and non-metals. Next classification is for the noble gases. Noble gases, inert gases, rare gases. They are the stable gases that are gaseous in nature, less reactive, or you can say unreactive, and they occur in the free state in the air in a very small amount and very trace amount, and they exist as monoatomic molecules. So noble gases, the next classification for elements, that they are gaseous in nature. They are stable gases, and since they exist in a very small amount or rare amount, they are also called as rare gases. So what is the four classification for elements? One is your metals, non-metals, metalloids and noble gases. So if I give you an example, like if I say you iron rod, if I say you silver, if I say you gold, if I say you sodium, potassium, oxygen, nitrogen, or a piece of copper wire, you can very well identify on the basis of these properties whether it is a metal or whether it is a non-metal. Then metalloids, which show the property of both metals and non-metals. Noble gases, rare gases, helium, neon, argon, krypton, xenon and radon. These are the rare gases. Stable gases, their outermost shell is complete and all the elements are in a race to attain this stable gas configuration. I hope this is clear with the elements. Now, when you further classify pure substances, you classify it into compounds too. You classify it into compounds too. The compounds are further classified as organic compounds and inorganic compounds. Classified as organic compounds and inorganic compounds. Organic compounds, the compounds again is a pure substance that is made up of two or more elements combined chemically in a fixed ratio by weight and can be broken down into elements by chemical methods only. So if you further classify compounds, which is again a pure substance, we classify into organic compounds and inorganic compounds. When we see the 118 elements, among that 118 elements, carbon is one of the elements. So if carbon is present in any of the compound, in any of the molecules, then this is said to be an organic compound. Another carbon, if there is a compound with other elements, then that is called as an inorganic compound. So further classifying pure substance into compounds, compounds classified into organic compounds and inorganic compounds. So when we see the example for a compound, we have carbon dioxide, we have water, we have HCl, we have calcium oxide, zinc chloride. These are all the formulas of the compounds, which can also be called as a molecule, a heteroatomic molecule made up of two different kinds of atoms. When we study the characteristic properties of a compound, the first is that is homogeneous in nature. Homogeneous now comes as having the same composition. Having same composition. Once it formed, it will be having the same composition. It has a fixed composition by weight. Like if I talk about water, for example, hydrogen and oxygen. Hydrogen and oxygen are combined in a fixed ratio of 1:8. The ratio is fixed, the weight is fixed for that particular compound. So example is water, where you take water as an example where the ratio is 1:8. A compound is formed only by a chemical reaction. Chemical reaction means when we talk about the molecule formation or a simple atom, an atom is the smallest particle of an element that takes part in a chemical reaction. So when two atoms combine, let's suppose I am talking about oxygen, this is forming a molecule here, a molecule of oxygen. This molecule is formed by the kind of bond that is present between the two atoms. Yeah, so this is a homoatomic molecule. But when I talk about water, I say hydrogen when combines with oxygen results in the formation of a compound that is water. Now this water that is formed is homogeneous in nature, but it is formed only when a chemical reaction takes place. So the constituent elements in a compound that is there is having its own properties. Water is having its own property. Hydrogen present in it is gaseous in nature. Oxygen present in it is gaseous in nature. But water that is formed is liquid in nature. So the properties of a compound are totally different from its constituent elements. This formation of a compound is accompanied by liberation or absorption of energy. Means there is some kind of energy change. Whether the energy is liberated, whether the energy is absorbed. But there is a kind of energy change involved. When you talk about energy change, there are two different kinds of reaction. One is an exothermic reaction. Exothermic reaction means where the energy is, heat energy is liberated. Heat energy is liberated in the chemical reaction. When you say it as endothermic, that means energy is absorbed. What is absorbed? The heat energy is absorbed. For example, if you take a little amount of glucose, when you feel dull or when you feel low, you take a little amount of glucose and put it on your tongue. So what happens? You feel cool. What has glucose done? It has absorbed the body heat. This is an example for an endothermic reaction. So when you summarize the properties of characteristics of a compound, that it is a pure substance, it is homogeneous in nature, the constituent elements are mixed in a fixed ratio by mass, and the product, that is the compound, has its own set of properties different from that of the elements. So this is basically the classification for pure substance. When we talk about impure substance, we say that impurity is present in it. So impurity present in it means that it has to be a mixture. A mixture can be further divided into two different types. One is your homogeneous mixture and one is your heterogeneous mixture. Homo means same composition and hetero means different composition. Homo means same composition and hetero means different composition. Like if I take for example salt and water. So when I add salt to water, what is going to happen? The salt is going to dissolve in water. So that water now that is present is salty water, uniformly dissolved in it. But in place of salt, if I take soil, okay, if I take soil and add it in water, you will see the different layers that have been formed in water, either of the pebbles, either of the leaves. So these layers can be separated there. So this is a heterogeneous mixture. Soil is a mixture, air is a mixture, but what is present, whether it's present uniformly, the constituents are present uniformly, or they are having their own set of properties with different composition. Okay, so here mixtures are divided into homogeneous and heterogeneous. So salt in water or sugar in water are example. Salt and sugar in water are example for homogeneous mixture, and soil in water. Soil in water is example for heterogeneous mixture. So, if we summarize matter, classification of matter, matter can be divided into pure substance and impure substance. Pure substance further divided into elements and compounds. Elements further divided into metals, non-metals, metalloids and non-metals, metalloids and noble gases. And compounds divided into organic compounds and inorganic compounds. Mixtures divided into homogeneous and heterogeneous. Hope the concept for the three types of substances, that is elements and compounds as pure substance and mixtures and as pure impure substances, clear to you. Thank you so much.